Hello and welcome to the Analytics Edge, sponsored by NetSpring. This episode features an interview with Amit Prakash, co-founder and CTO at ThoughtSpot. In this episode, Amit talks about his journey in helping create ThoughtSpot, how data leaders should be thinking about large language models, and the impact generative AI will have on business. Now please enjoy this interview between Amit Prakash, co-founder and CTO at ThoughtSpot, and your hosts, Thomas Dong, VP of Marketing at NetSpring, and Vijay Ganesan, co-founder and CEO at NetSpring.
Analytics Edge is a podcast about real-world stories of innovation. We're here to explore how data-driven insights can help you make better business decisions. I'm your host, Thomas Dong, VP of Marketing at NetSpring. And for today's episode, my co-host is Vijay Ganesan, co-founder and CEO at NetSpring. Thank you for joining me today, Vijay.
Thanks, Tom. Looking forward to this.
All right, Vijay, you know our guest very well. Back in 2012, you both co-founded ThoughtSpot with a few others. Amit Prakash is now, of course, the CTO at ThoughtSpot, and ThoughtSpot is a market-leading business intelligence platform that helps anyone explore, analyze, and share real-time business analytics and data easily with AI-powered analytics. Amit, thank you so much for being with us today.
Thank you. It's a pleasure.
Amit, welcome. I've been looking forward to having this conversation with you. I've seen you in action at ThoughtSpot, the brain behind ThoughtSpot search and AI technology.
All right. And today's topic is all the buzz, large language models or LLM. Generative AI has, really become a mainstream topic, even in the media. New York Times, Wall Street Journal, they're all writing about it. Its impact could, of course, be of the same scale as the internet and mobile. It's been proven to outperform humans in many tasks, sometimes by orders of magnitude. But before we dive in any deeper into today's topic, Amit, could you, tell us how data leaders should be thinking about LLM, generative AI more broadly?
So broadly, generative AI could be like a DALL-E generating images for you, or imagine generating video for you, or a GPT generating body of text for you. Large language models is kind of a narrow field inside generative AI, where language modeling basically means given a body of text, you want to predict the next word. And the large part of large model is basically we're doing this with help of really, really large neural networks, in particular transformer networks.
Yeah, that's very, very helpful. And obviously seeing many of the product announcements coming out of ThoughtSpot, where you're starting to embed some GPT capabilities into your Sage offering. So maybe let's take a moment and you can just walk us through your career journey in analytics, where you started and how you ended up at ThoughtSpot and helping found that company.
Yeah, sure. So right after finishing my PhD, I joined a small group at Microsoft, maybe like 5 or so engineers. And that team grew a little and went on to build the very first web scale search engine that eventually became Bing. And so over there, I was responsible for a piece of search engine that's called static ranking, where like before the query arrives, all the different signals that you can put together from the web graph and usage and other things to be able to rank web pages. And then after that, I spent about 5 years leading a team at Google, where my team was responsible for both building the infrastructure for training large-scale machine learning models, as well as training those models to be able to predict the likelihood of somebody clicking on an ad in a given context. So as you know, most of Google's revenue comes from that ad. And so what we were doing was critically linked to Google's revenue. And every quarter we were on the hook for improving models in a way that increases revenue by a couple of percent. So as a result, we had pretty much infinite resources at our disposal, and we were training machine learning models that were 2 orders of magnitude larger than anything else happening in the world. So that was a lot of fun. We added a lot of revenue for Google through that team. And then I started ThoughtSpot, where the key idea was that in order to be truly data-driven, you can't really work with static dashboards and reports that were conceived 6 months ago. You need to be much more dynamic. You look at data and that produces a question in your head, and then you ask that question, and then that produces another question, and that's how you get to your 5 whys. And that's just not possible in sort of traditional BI product thinking, where there's a separate producer team that's producing data insights, and there's a consumer team that's consuming these insights to make business decisions. And we wanted to shrink the gap between when somebody has a question, when they get answer, from like what used to be weeks to a couple of seconds. And that's been the vision of ThoughtSpot always. Vijay and I kind of worked on the foundation of this thing.
So it sounds like you've definitely, with ThoughtSpot, really moved the needle on this democratization of analytics that everybody's been talking about for years and years and years. Reducing the complexity of the tools and even the process behind it, the people who need to support that. LLM seems to be the missing link that you guys have been able to add very recently into the product. I'm just curious, though, does this introduce any new or different types of challenges with this type of capability?
So what most people are worried about with LLMs is hallucinations, where they will give you convincing answers to questions that are wrong, and you don't know that it's wrong. And we've been largely successful at eliminating that for the use cases that we care about for 2 reasons. One, we don't take the output of LLM right away. LLM generates SQL, we run that SQL, and then we give you the output. So the output is always grounded in real data in a database. But the SQL query could be wrong. The best tool for eliminating hallucinations in LLM is to use them only for reasoning and not for their memory, because they have faulty memory, right? So if you can bring everything that is relevant for answering a particular question into the prompt itself, then LLM is not relying on its faulty memory. It's just doing sort of the reasoning part necessary to pick these pieces together and translate that into SQL. So that's one thing. The other thing is that because we had already invested a lot in doing this without LLMs, we are able to take care of a lot of this complexity and not expose it to LLM. As a result, the LLM's task becomes much simpler. So to give you an example, suppose if you ask, how much revenue did I get from California? You may be asking it from a data model that has potentially 1,000 columns and 1 billion rows. What we can do is that we can figure out that this question is about the revenue column and the state column that live in 2 different tables, and we know the join path and everything. So what we feed LLM is basically a very small table that perhaps contains revenue column and state column only, and it has only 2 rows, maybe one of them is California. And so what that allows LLM to do is ignore all the other complexity about which column to go after and how to join these things and things like that, and also not have a confusion about whether it's California or CA in the database. So it can generate SQL. Now, this SQL cannot be run against Snowflake or Databricks or something, right? Because it's supposed to be SQL on this pretend table with just 2 columns. So then we can take the information in that SQL and translate that into real SQL that needs to be run across real data. So that's how we've been able to eliminate the hallucination problem.
Okay, right. So yeah, to build trust, at least within your user base for this very specific use case. But there's a lot of startups out there who are trying to build, the tooling and infrastructure around LLM. Just curious if you could maybe talk us through maybe some of the other considerations, to be able to build like a trustworthy AI system.
Yeah, so it really depends on the application.
Mm-hmm.
There is a continuum of approaches that you can use to build trust. The first one is obviously human in the loop, where LLM is just generating a first draft, and then somebody is reading it, verifying it, modifying it, and then putting in front of the end user. And for example, if you're giving a medical diagnosis, that's the only way to do something like that, right? The next one is where you have trained another model that's just classifying the output as to whether it's acceptable or not. So, for example, if you want to eliminate any offensive output from the model, you could put another model in front of it that just classifies the output, whether it's offensive or not. That's a much easier problem than actually generating the text, right? So, and the next one, which is kind of where ThoughtSpot is let's say you're trying to go from natural language to SQL. For our end users, that SQL may be impenetrable. Like they don't know what's going on, how to understand it, how to modify it. But if you introduce an intermediate representation that the end user can understand and modify themselves, then it completely changes the game. So in case of ThoughtSpot, you ask the question in natural language, it gets translated to the keyword search syntax that ThoughtSpot has, and then that keyword search syntax gets translated into SQL. That keyword search syntax is very easy for any business user to understand. So they will know right away whether that translation was correct or not. And if it's not, then they can modify.
Well, maybe let's switch gears a little bit here and talk through some kind of technical implications for all these practical applications of LLM. I know, Vijay, you've been thinking a lot about applications of AI here at NetSpring as well as over the years. Why don't you lead us through a quick discussion here and maybe some of the nuts and bolts of implementing LLM?
Very exciting to double click on some of the things you alluded to about use cases of LLM in analytics. So as I think about this, there's really three areas which I'd love to get your perspective on where potentially LLM could be very effective in enhancing analytical capabilities. One is making it easy to ask analytical questions. So I'm a business person. I have a question in my mind about my business. How do you make it very easy for me to ask that question and get an answer without having to learn a new tool and stuff like that? So sort of extensions to some of the things that you've done at ThoughtSpot and what specifically LLM helps in that area. So the second one is interpretation of answers. So I'm looking at some visualization. A lot of times people struggle with interpreting data that they're seeing, even if it's a pretty chart. It's how can LLMs help with interpreting the data and highlighting key aspects that they're kind of in the data that I'm looking at, but not quite obvious, right? And then the third thing, which is the holy grail of analytics, is, well, hey system, can you tell me something interesting about my data, about my business that I don't know, and I don't want to bother with asking any questions. You should know what I'm interested in and give me the answer, right? So these three areas and any other areas that you can think of, how does LLM play a role?
Yeah. So the first one is, I guess, pretty obvious that I'm a business user. I have a data question. I have a particular way of phrasing the question based on how I think about these business entities. How do I bridge the gap between the way I can think about it versus the way the system needs it, right? Like I may be thinking, how much ACV is likely to be closed this quarter. What is likely to be closed this quarter means? It means maybe that the AE has put the opportunity in a commit category, and it means that the close date of that opportunity is within the bounds of the beginning and the end of this current quarter based on today's date. Right? So being able to make those decisions, starting from that sentence to all the way translating to SQL. And this has really profound implications for how much value you can get out of data. A quick example I can give is that we were training a set of people who work on trading floor. And their job every day is to pick up the phone and negotiate with a bank how much they're going to pay for borrowing securities from some other bank for something that they're trying to do, right? And so these are people who are spending most of their day kind of looking at numbers and making calls and negotiating with another human at the phone. They are not data savvy. They're not SQL savvy. They're never going to do anything about data unless they had a tool like ThoughtSpot Within that training, one of these traders figured out that they were getting overcharged by a particular bank to a tune of $2 million a year compared to all the other banks. So there was some sort of a price gouging being done by one partner bank that they had. And this person had enough sort of business context to be able to ask that question and make that comparison. But without the ability to ask that question, this question would have never been asked, because the people who are sort of doing analytics are not thinking in those terms. And I've got example after example where, like, when you enable the person who has the strategic and tactical responsibility of making decisions gets enabled to ask data questions, they ask very different data questions and create a lot more data value. The second one you talked about, which is explaining what's going on with the analysis, I used to chafe at that one, to be honest. I was like, the chart is right there. You can see the line is going up and then coming down. Why does somebody else need to tell you that it peaked in April and then it dropped 20% after that? Like, what's the point of all that? What I've learned over time is that these things are useful for two reasons. One, there's a lot of human labor goes into writing these things for purely regulatory purposes. And it's just like work that nobody wants to do. You're just reading a chart and you're writing something, and then it's just a requirement that you need to do. And automating that has a lot of value. But the second is that there are a lot of busy execs out there who don't even want to go into a dashboarding tool and look at the numbers. They just want the summary of what they would glean from that dashboard. And it makes sense to extract that summary and send it to them. So what you can do is you can figure out what are the most common things that people take away from the data, which is like what's been trending up, what's been trending down, what are the patterns, where the correlations are. And you can search for existence of that in the output data. And then it used to be that when you try to describe it, you had to fit the numbers you computed into a template, and it used to read pretty robotic and annoying to read. And now with the advent of LLMs, you can actually have a very fluent language. In fact, I've seen research papers where people are trying to figure out what are the right prompts so that the output that comes out looks more like what a journalist would write. And it has sort of that catchy title and catchy description as opposed to just saying it in a bland way. So there's some interesting work going on there. And we are working on sort of narratives as well. But what we are doing is trying to go one level deeper than what you can see on the dashboard. So what you might see on the dashboard is that a particular KPI that you cared about dropped by 10%. But if we see that, then we will also do the root cause analysis of why it might have happened. So when you get the summary out of dashboard, it's not just what you could glean from the dashboard, but one layer deeper. And you can obviously go one layer deeper everywhere, but the intelligence lies in focusing where it matters to go deeper. And then the last thing that you talked about, which is being able to tell something that the person didn't even ask for. You and I both know this example very well, where there was a bank down in Australia where they ran sort of our AI insight capabilities, Spot IQ, and they found that there was a lot of insurance claims that they had paid out, but they were supposed to be paid out by somebody else. But because of software bug, it was sitting in a queue that no one was looking at. And it was costing the bank to the tune of $20-30 million. And sort of one invocation of finding anomalies in their data in an automated fashion surface something like this. We've seen other examples where abuse in travel policy costing company millions of dollars extra that got exposed through this. So this was possible to do even before LLMs. There is an interesting idea that I've been brewing for a while, which is what happens is when you're looking at statistical anomalies, some of those are truly a surprise to the human being sitting at the other end of the computer. And some of those are just statistical anomalies, but not real anomalies in the sense that the person already knew. Like, for example, if I tell you that you had a lot more sales during Christmas week, like the week before Christmas, than any other week, it'll say, tell me something I didn't know. Right? So that creates a lot of noise, and that hides the real insight from people's view, because you have to go through 20 supposedly insights to be able to find one real insight. And you might get bored and never look at that 20th one, right? So the trick there is to be able to capture the mental model of the end user so that you know what they're already anticipating. If they're already anticipating an increase during Christmas season, you can see that from sort of previous trend. If they're already anticipating the amount of revenue they produce from a particular state to be proportionate to the number of stores in that state, can you capture that? And then that way you can denoise these insights, and meaningful insights surface a lot more. And that requires a two-way conversation between sort of the algorithm and the end user. And these are the kinds of things that you can do with LLM that wasn't possible before.
A question on, which is a very fundamental question about LLMs and analytics and analytical computation. So if you look at sort of the more common examples that you see of LLMs, it's very text and human language oriented. Now, how does that same set of concepts apply to analytical computations? Does it translate? Is there something more that has to be done? Does it have to be specialized LLMs? How does it translate?
So the most powerful application of LLM that I can see right now is code generation, right? And so anything that you want to automate, including data tasks, hopefully you can describe it in simple terms, and that generates code, and that code does the task for you. And that's really the way I feel like it's going to be in analytics. Now, the largest LLMs out there today, like GPT-4 and Claude and Bard, are all trained on enough code that they can do code generation out of the box. And then there are more distilled models that were specifically trained on code generation. So one definite advantage these models have is that they are much smaller, so the latency and the cost of inference is less. They may also be better at some of the code generation tasks than general purpose ones. But in general, the larger models tend to have more common sense reasoning capability, which makes it easier for them to fill the missing gap in the task description in natural language. So I think the jury is out whether you're going to prefer a distilled model just for code generation or a general purpose large model.
So you talked about institutional knowledge, right? And for analytics to work well, you need a lot of context, right? You need to know a lot about the business to be able to come up with intelligent analytical insights. There is, of course, the prompts that you can use in ChatGPT about weather or writing an essay or things like that, where it's using the corpus of everything that's available on the internet to be able to come up with a good answer. But how does that translate to data? Because a lot of data is sitting inside within the enterprise, within enterprises and databases, data warehouses, and it's not the same as all the information that's available on the internet. So that institutional knowledge that is necessary for coming up with good reasoning and intelligence, how do you make that work on data which is sort of sitting inside sort of walled gardens of enterprises?
Yeah. So the most interesting thing about these large language models is what's called in-context learning, where you describe some information in the prompt and it's able to learn from it and generalize it very quickly, as opposed to sort of classic training, right? So for example, if you insert a sentence that in most cases in this company, ACV is a representation of revenue, and then you ask a question about ACV, it will be able to pick up that instruction and interchangeably use ACV and revenue. Or if you describe the signature of a function, like this is a function that, I don't know, turns a date into the quarter, and then ask it to generate code that requires use of that function, it will start using that function. So most of the times, the right answer is that you pick up the relevant institutional knowledge and inject that into your prompt. And that's why vector databases have become such a huge thing lately, where what you do is you take all that institutional knowledge that's available in a written form, and you chunk it into paragraphs, and then you create a representation of that paragraph's meaning in vector space through embeddings, and then you store that in a vector database. So when you're trying to answer a question, you will turn that question into an embedding as well, and then you do k nearest neighbor search in the vector database, and then you find k relevant paragraphs, and then you inject that into prompt, and then you ask the LLM to do whatever it is you're trying to do, answer a question, generate code, or things like that, right? So that's one way to inject institutional knowledge.
And this is sort of ties into what you were saying earlier about you want the intelligence and the inference, but you don't want memory, right?
Yeah.
That's what it relates to.
Yeah. The thing with this approach is that right now the context windows are somewhat limited. So the most common sort of context window that's available to people is somewhere around 2,000 to 4,000 tokens. That gives you a couple of pages worth of text, or maybe at most 10 pages worth of text that you can put in there. People like Claude was talking about 100K context window. GPT-4 has a 32K context window version of model as well. And then there are papers out there with 1 million token context window, which allows you to put really a lot of information. And that way you don't have to worry about whether you got the right information in there or not. The other way is fine-tuning, of course. So you can pick up a model that was trained with public data, and then either you can retrain a few layers, like the last layers of that neural network based on your data, or you can sort of let everything be perturbed with your training data. And that way you're able to push the model a little bit towards your use case and let it learn a little bit more about your use case. So if you have, I think I've heard numbers from anywhere from like 10,000 to 1 million sort of instances of training data, then it's a reasonable thing to do is to pick up a model and fine-tune it for your use case. Obviously, it costs a lot more to fine-tune than to just do prompt engineer. But it's an investment that, in some cases at least, totally worthwhile, and the cost of fine-tuning is going down substantially.
Switching gears a little bit, let's talk about modern data stack and data warehouses. So as we know, the data warehouse is becoming the center of the universe for data in enterprises, right? Everything is coming to the warehouse. Even the kinds of data like product instrumentation streams or IoT, data that, 10 years ago would never reach the warehouse. Today, it's reaching the warehouse. So the warehouse is becoming the center of the universe. What does that mean for LLMs? Specifically, I was reading recently about Snowflake acquiring a startup to inject more generative AI capabilities inside of the database. Now, data warehouses have always had machine learning type capabilities embedded in where you can use these things as simply functions in SQL. So are we going to see more of sort of LLM functions that you can use in a warehouse and within SQL?
I think LLMs are pretty powerful generic functions as well. So you can, for example, if you're trying to do a classification task, you can give it like 3 examples of how to classify things, and it does a reasonable job after that of classifying things based on like everything else that it knows about. So instead of invoking a classifier, you could just give a prompt. Obviously, the advantage is that you can get this without having to create a lot of training data and training a new model. You can get these things done much more easier. Obviously, the inference time with these models is in order of seconds. And so if you're trying to process even 1 million rows of data, that's a lot of compute and a lot of wall clock time. So I think things will evolve. Probably faster, smaller models will see its way to do these kinds of things. I've also seen people try and train LLMs over tabular data, like rows and columns. I haven't seen that many successful use cases out of that, but it's definitely an interesting idea that's worth exploring. And we'll see how that evolves over time. And then, like all other complex applications, LLMs can be a pretty useful assistant or co-pilot, like for auto-completing SQL and giving you the rough syntax of what you need and invoking stored procedures and things like that. So I can definitely see that sort of stuff also being there.
Organizationally, how should a CDO think about LLMs? Are we going to see like AI groups being formed? How should, ownership of data? There's a lot of training data. What happens to the ownership of the data, and how does, who owns the models? The transparency of these models and things like that. So just from a CDO, CIO perspective, CTO perspective, what would be your advice in terms of how they should think about structuring themselves organizationally with all of these new things coming in?
A large majority of the cases, you don't need to train your own LLM. I think accessing public LLM through API is the right thing. Of course, you have to make sure that you have a secure setup where your data is not leaking out into a public LLM. And there are ways of doing that, like when you have an enterprise agreement and you're making API calls, none of that is getting persisted with the large providers, at least. If you do start fine-tuning or training your own model, then you have to worry about your data pipelines being clean and reliable, versioning your models and going after the right version, worrying about the drift around it, and things like that. And that will require a lot more sophistication. There are some tools out there for sort of managing versions of your training data and your trained artifacts that you can use. Organizationally, I think it's still very new. So I don't think sort of a proper discipline has emerged out of it, but a lot of what happened in classic machine learning or data science still kind of applies here. So I think those best practices will still continue to be a good thing, where you're doing your test and train separation, you're versioning your data and your model, you're monitoring your data pipelines for quality, you're monitoring your model outputs for drifts and things like that.
So speaking of best practices then, Amit, I know that we were chatting the other day about this new meetup for generative AI that you've been involved with. Here's a chance for you to promote that a little bit.
Yeah, no, thanks for bringing that up. So, last 6 months have been crazy, and anybody who's been trying to stay on top of this thing has realized that that's a very hard thing to do. And even like yesterday, our guest, Sven, was saying that most AI researchers he knows kind of secretly feel that they are behind as well in catching up, because like every week there's a new paper and you need a few hours to be able to read it. So the idea behind creating this monthly generative AI meetup was that we can all learn together and help each other out. So this was the very first one that we did. About 100 people registered, and the managing director of Coastal Ventures, Sven, was leading the discussion, and it was fantastic. And we hope to continue this and have a fantastic speaker every month, and have a engaged community around it where people are asking great questions and we are learning together. If you search for ThoughtSpot Generative AI Meetup, it should show up.
Well, thank you so much for joining us today, Amit. This was a fascinating conversation on one of the hottest topics out there. It was a real pleasure to have an expert in the field like you share your experience to date and wisdom and thoughts for the future. So again, thank you very much for joining us today. Vijay, any final thoughts from you?
It's always a pleasure talking to you, Amit. Always deep insights, well thought through and well presented. Really appreciate it. And I'm sure our viewers would benefit greatly from this. Thank you so much for doing this.
Yeah. Thank you. It was a wonderful conversation. I enjoyed it. And thanks for hosting me.
All right. Well, that was a really fascinating conversation with Amit here. There was just so much there to distill. Maybe, Vijay, why don't you take a stab at summarizing your key thoughts out of today's show?
Yeah, it was a great discussion. Amit's a great thought leader in the space, and it's wonderful to have an expert in the space on our show. One thing that I found interesting in what Amit said was this idea that you want to leverage the reasoning and the intelligence of LLMs, but not necessarily the memory, right, to avoid hallucinations. And so his approach of, vector databases and leveraging that and then feeding the appropriate context to the prompt to avoid the hallucinations, I thought that was a very interesting idea, which I hadn't thought about before.
Yeah, absolutely. And for me, kind of from my own journey in analytics, thinking kind of the massive business impact and potential here, I think back to like 2011 and pop culture when AI suddenly became mainstream with the Jeopardy challenge of Watson over at IBM. And it's taken us, 12, 13 years here now to come up with like viable commercial applications of it. And, some of the discussions that we had around trust around these systems is really been the challenge of really any analytics application to really receive kind of the widespread adoption, right? People need to trust it before they're able to use it. And when we thinking about using them for reasoning, I think he dropped the terms, they're great assistants, they're great co-pilots. That's where we are today, right? And it's proving to outperform humans on many tasks by giving us that that ability to cover that first 80% with these technologies, but still have humans to finish that last mile or last 20%. And so really, the potential is still there, right? We're only scratching the surface of what these tools and technologies can do. And as we become more confident and trustworthy in these systems, they will certainly move beyond just assistance. And I'm sure humans will happily, in select cases, allow it to completely automate some processes.
Yeah, and he gave us a couple of examples of how a business person could get tremendous value from this system, right? He was talking about a trader that was able to detect, some fraudulent commissions or with a partner bank and so on, right? And there's something interesting concept there, which is the way a business person thinks of analytics is very different from the way a data person thinks of analytics. So there's always an impedance mismatch there. And with LLMs, it makes it easier for a business person to ask and get answers without having to translate that into something that a data person understands. So that really opens up phenomenal opportunities because the data person cannot think the same way as the business person thinks and vice versa. And so we're stuck in this world where the business person has some idea in their head, but then it's lost in translation. And so you don't get to the analytics. Whereas in this world now with LLMs, that you don't have that impedance mismatch, right? So to me, that struck me as some great examples of how this is going to really take analytics to the next level.
All right. Thanks again, Amit and Vijay, for helping me co-host today. That concludes today's show. Thank you for joining us, and feel free to reach out to either Vijay or myself on LinkedIn or Twitter with any questions or any suggestions for future topics. So until next time, thank you very much.